Thanks for the introduction, Caroline. Hello, everyone. Welcome to my session on Replication in Pulsar. For today, my agenda is to get you familiar with the ins and outs of the Replication and how to configure it so that there are no surprises. First, about myself. I am a senior software developer in Flipkart, and I've been managing Kafka cluster of about 300 nodes for the last 3 years. We have an in-house push-based central messaging platform, also built using Kafka, but we are actually in the pursuit of migrating to Pulsar. Why is that? Well, there are lots of reasons actually. Recently we did the evaluation of Pulsar, and we found various features important to us, like horizontal scalability, multi-tenancy, and replication. But we will keep our focus on replication for this session. What makes the replication so important? Well, in present times, users don't really expect any kind of downtime. Even in the case of large-scale disaster scenarios, for mission-critical application, it is a must, but it is also important from the business continuity perspective. The replication allows us to have simply offshore backup to avoid any full-scale data loss. And in general, it allows us to have a multi-region deployment where we can still serve, we can be more available and still serve user requests from any region if required. Right? So it has a very large role in having a better availability. In Pulsar, the replication comes out of the box. It provides a basic construct of the global topics. There we can, the producers can produce messages from any region to the same topic, and the consumers can consume all the topics irrespective of regions where they were produced. The construct is generic enough that the platform owners can make more features and more constructs on top of it, like an active passive topic, for example. In Pulsar, to have the replication, there is no additional components to maintain, which is a huge plus. So let's see how the topics are actually replicated in Pulsar. The topics are actually covered under various layers. The tenant being the broadest layer, and there we have the ability to provide a cluster list, which kind of tells the namespace and the topics where they can have the replication. Right? It's a way of doing multi-tenancy and cluster gating, right? And once the tenant is created, you can actually create your namespaces and specify the exact list of replicating clusters. And the topics under that namespace will automatically start the replications across the mentioned clusters. From the CLI perspective, the usage is pretty straightforward. The tenants in the namespace both have the -c flag. And as you can see that the tenants cluster list has to be the superset of the namespace cluster list. Right? Once the namespace and tenants are created, the topics, any topics that are created under the namespace will be replicating across the clusters mentioned in the namespace. It doesn't matter if the topics are partitioned or non-partitioned, or they are persistent or non-persistent. But in the latest version of 2.7.3, we see that there are some inconsistencies in the behavior of the topic creation. If the auto topic creation is false, then we see that the non-partitioned topic doesn't really get created in all the clusters automatically. You have to do it by yourself, and only then the replication will begin. But for the partition topic, it works flawlessly. You create it in one cluster, and the other replicating clusters will have the topics automatically. And then you can just start the produce and consume anywhere in the cluster. And you will. Yeah. So how are these topics replicated? These replicator is basically a core component, and it is kind of a special consumer of the topic, and it is maintained by the broker. So once the partition or the topic has been created, the broker will start a replicator for that topic for each of the remote cluster. So we have a replicator for each partition remote cluster pair, right? And there it will try to get the Pulsar client for the remote cluster. And after that, it will try to create a produce for that specific remote topic. And post that, it will schedule the asynchronous task to fetch messages from the ledger, bookkeeper ledger, and it will subsequently push those messages to the remote topic. Right. So I've marked these lines basically, and these lines can be tweaked by the configuration. We can tweak their behaviors using the configuration that is exposed by the Pulsar broker. So we will now go through them one by one. So the brokers, they will actually cache the Pulsar client instance per remote cluster. So there's only one client per remote cluster. There you can configure the maximum number of connections that we can have per remote broker. Default is 16, which I think is more than enough for most scenarios. But having multiple connections do help in the case of high throughput and large partition and many partitions when the interbroker connection is actually latent, right? The broker client TLNC enabled, it is disabled by default, and the good practice, I think, in general, is to enable it for extra security. There was another configuration, which is replication TLS enabled. It is an old config, and I think it is deprecated now in the favor of more and broader configuration. When the replicator creates the producer, it disables the batching. So what it means is that the replicator fetches the entries from the bookkeeper ledger, and it will produce them as it is to the remote cluster topic. Just a quick refresher on the entries versus messages. So when a user is actually using the Pulsar client to produce messages, and if they enable the batching, then what can happen is that the messages will be clubbed together to form a bigger unit called entries. The entries will have multiple messages to improve the throughput and to reduce inefficiencies, right? So in summary, the users work with the Pulsar client and the messages, but internally the broker and the bookies, they will be storing in terms of entries, and they'll be talking in terms of entries, right? So the replicator will actually just fetch the entries as it is from the ledger, and it will push them to the remote topic. Why is it important? Well, when it creates the producer, it will specify the producer queue size, and it will buffer all the entries while sending asynchronously to the remote cluster. So if you happen to have the high entry rate per partition, right? The entries are very small. You are not getting much batching, and the entry rate is high. And the average latency across the cluster was also high. Then the queue size of 1,000 may become the limiting factor, and you might start to see the replication lag. So just a simple formula: if the entry rate per partition and the real latency, if it is in the ballpark of the queue size, then you should be fine. As I mentioned, the replicator is actually just a special consumer. So you can see its cursor information and in the admin CLI to stats command, and there you will have the name, and you can actually configure the name to something else if you want to. Okay, while the replicator fetches the messages from the bookkeeper ledger, by default it will ask for maximum 100 entries. If again, same scenario, if you have a high entry rate and the entry size are small, right? then the 100 entries per request might be less, and that might become the bottleneck, and you might not get enough read throughput to replicate basically, and you might see the replication lag again. So if the entries are small and the entry rate is high, then increasing it might help. The dispatch throttling rate configuration can be used to throttle the rate of replication, and it is also readable via the topic policy. So it is a dynamic configuration basically. But I think that it comes with a cost. If the rate of replication is throttled, then it has an effect on the subscription failover, which we'll see how it works. So, but yeah, there is a configuration to throttle the replication if required, but there is no outright way to disable or like stop or pause the replication temporarily, right? You can only throttle it. The replication throughput aggregates can be seen in the admin client in the stats command. It is also exposed, and if you have Prometheus set up, then you can see it there also. The replicator's cursor information will be available in the stats internal command. Now that your topic has been configured properly and is replicating properly, it's time to move on to the consume side of things. So for example, in this case, the two clusters are there and two producers are producing independently in two clusters. And these are one consumer, which is just printing the messages. And we see that it can see all the messages. And at the moment is in the middle of consumption, and it has acknowledged 4 messages, right? That's why the cursor position is 4. So what happens if, let's say in one cluster, the Pulsar deployment itself becomes unavailable, right? And the other scenario is also possible where the Pulsar is fine, but your consumer application itself is seeing the outage, right? And you have no way to actually bring it up very quickly in the same place, right? What you can do is you can basically start the consumer in the remote cluster, the remote replicating cluster. And what you should see is that the replication starts from almost the same point. You can see some duplicates, but it will be around the same point. There will not be any data loss though. But for this to work, you can see that the subscription is marked with a star because it's a special subscription. The normal consumers don't have this behavior. They don't support the fallback failover feature. So, and also the consumers have to connect to the broker in the remote cluster with the same subscription name. If they use a different subscription name, the behavior will be different. They will either start from the earliest or the latest offset, depending upon how the consumer was configured. So yeah, so to make it work, you have to first tell the broker to do some bookkeeping for a subscription. The normal consumers don't support this. To have the failover, you have to enable the replicate subscription state. This will tell the broker to actually map your subscription's cursor offset to a corresponding offset in the remote cluster, right? Periodically. And yeah, periodically. So if you decide to switch the consumer from one remote cluster to the another remote cluster, because the broker is continuously mapping your subscription offset, you should be able to resume the consumption in the remote cluster. Right. Matthew actually explains this in very detail, wonderfully in his talk, taking replication to the next level. It is available on YouTube, and you can check it out. Here, I will not go through in detail, but I will actually mention the summary for the clarity purposes. So what happens is that periodically, the broker will try to establish the mappings between the topics offsets across all the replicating clusters, right? It will send the requests few request and response cycles happens, and the broker sends the request, the wrapping cluster responds with their own topic offsets, and the broker can establish the mappings of the topic, and that is returned back to the same topic as the marker message called the replicated subscription of snapshot. Again, the Matthew actually explains how it is established and how it works correctly in his YouTube video. But here the snapshot object actually just has the mapping of the offsets. It contains the local message ID or the offset and the corresponding offset in the replicating clusters, right? So this happens periodically. So periodically snapshots will be established and will be returned back to the same topic. These snapshots are not replicated to the other clusters because it is not useful for the other clusters actually. So what happens is that when you create a subscription with the replicate subscription state enabled, the brokers which have these subscriptions, right? The brokers which are owning these subscriptions, only those brokers actually tries to establish these snapshots. So if the other clusters have their own subscriptions, other subscriptions which are also replicated, so they will do the same thing on their side. Now with all these snapshots in the topics, what the replicated subscription will do is that while it is going through the topic ledger, it will encounter these snapshots periodically, and it will try to maintain the last few snapshots in memory, right? And for example, in this depiction, we have S1, S2, S3 snapshots in the topic itself, and there's a consumer which has acknowledged up to the message C, and there the delete marker is 7. The read marker is few messages ahead, let's say 10, and till up to this point, the subscription one has encountered all these snapshots. But let's say that it is only maintaining 2 snapshots, last 2 snapshots. So here it is S2 and S3. The S1 can look like, let's say the cluster B's 4 position is mapped to the cluster A's 2 position. And S2 will say the 6th position cluster B is mapped to the 4th position cluster, right? And you can actually see how this mapping is actually correct, right? There's no message loss if you translate from B's 4th position to the A's 2 position. You can see extra messages if you do the failover, but there's no message loss. So when the subscriptions delete marker is advanced, let's say that in this example, the delete marker just became 7, right? Then what subscription will do is that it will actually refer the cached snapshots, and it will find the snapshot which is just below your delete marker. And it will use that snapshot to map your offset to the remote cluster. So in this case, the S2, which was on the position 6, can be used to map your delete marker 7 to the marker 4 in the cluster A, right? And to do that, what the subscription will do is it will actually create the update marker and push it into the same topic for the replication. Once the replication has done, the remote cluster, the replicator in the remote cluster will encounter this update marker containing the mapped offset, and it will use that to update the subscriptions cursor position. So here, once the U2 reaches the cluster A, the subscription one's cursor offset is set to 4, because the subscription offset in the cluster B was set to 7, right? So at this point, if you actually try to do the failover, you will see that you will start reading from 4, but You will not miss any messages. You will do encounter the message C twice, but that's it. So yeah, from the configuration side of things, the replicated subscription snapshot frequency millis will dictate how often your snapshot should be taken by the broker. By default is 1 second, which is frequent enough so that you will only you will see duplicates of around 1 second only. The overhead is small enough that you don't have to worry about it. But to achieve this, the broker is actually writing a lot of marker messages, right? To establish the snapshots, it is sending requests. It is doing request response cycles to establish the snapshot. It is writing the snapshot to the same topic, and the replicated subscriptions, when they move their delete markers, they will be publishing their update markers also to the same topic. So all of these markers will be published to the same topic, and they will be taking their own positions in the ledger, right? So let's say that if you're if you have a subscription and that is stopped for now, and there's no produce happening, right? But you just happen to have one replicating subscription on. Because of that, what will happen is that the broker will try to do all of this bookkeeping and will keep writing these marker messages in the topic, that even if your subscription is stopped, your lag in the, let's say for Grafana or in the admin API, you will see the lag is increasing, even though the lag is just comprises of all the macro messages. There's no real message in there, right? So if you don't have a large throughput, or you are okay with the duplicate messages when you do the failover, maybe it is okay to actually increase this to 5 seconds or 10 seconds. The snapshot timeout seconds will dictate the timeout behavior when the broker is trying to establish these snapshots, right? So the exact detail, again, the Matthew explains it very well. The broker actually sends the requests to the other replicating clusters inline the topic, so it is relying on the replication, right? And the remote clusters will respond back with their own offsets and through their topics via the replication again. So the replication actually plays a very important role here, replication. So if the replication lag is actually huge, and it is in terms of time, if the replication lag is more than 30 seconds, then basically your broker will actually time out and it will not be able to create the snapshot, right? So basically your timeout should be more than the round trip time of the message of the replication lag, basically the local to remote plus remote to local. Yeah, it should be worst of that. Basically. The max cached snapshots per subscription will allow you to configure how many snapshots the subscription to have in the memory for the translation purposes, right? So we saw in the previous example that the subscription was caching 2 last snapshots, right? Here we can configure it something else. By default, it is 10. It is required because the consumer actually is processing multiple messages in parallel, and it can even do the per message acknowledgement. So there are scenarios where the delete position, where the marked delete position is far behind the read position, right? Even if there's a single message for which the broker hasn't seen the acknowledgement, it cannot advance the delete position past that message, right? So there is a scenario. So it is totally possible that the marked delete position is far behind the read position. And if the difference between these positions is actually more than the time covered by the number of cached snapshots times the periodicity of the snapshot, then basically the subscription doesn't even have the snapshot to translate your current cursor position or the current marked delete position, right? It doesn't have enough snapshots to translate. So if you see that your marked delete position can be left behind, And if the 10 snapshots are not enough, then you can consider increasing it. The overhead should not be much because it's just a small object, so you can increase it without any issues. The other configuration is your to enable or disable subscriptions. If it is disabled, then you will not be able to create the replication subscriptions, and you will see the error while doing so. There are some gotchas that we actually encountered. You should be cautious about running the replicated subscriptions with the same name in the multiple clusters simultaneously, because both of the subscriptions will be doing their same things, translating their offsets for the other remote cluster. So basically, they'll be stepping on each other toes, basically. And if you happen to restart one subscription, then you'll basically see the undefined behavior. You will not be sure whether the offset was my previous offset or the offset because of the remote cluster. Also, the snapshot creation stops if one of the replicating cluster becomes unavailable. Again, that's because of your replication lag. If one cluster is unavailable, the replication will stop, and the request response cycle will not be complete, and the broker will not be able to establish the snapshot. And if the snapshots are not there, then your subscriptions will not be able to translate your cursor positions. So basically, if you do the failover after this, you will see a lot of duplicates. To resume your snapshot creation, currently the unavailable cluster has to be removed from the namespace, and there are repercussions to that, which we will get in some time. So as far as failover is concerned, it works very well in practice. Even in the case of high subscription lag, right? The snapshots are actually present in line topic. And if your subscription lag is, even if the subscription lag is 1 day and your topic retention is 2 days, right? You should be able to translate the subscriptions position to the remote cluster because the snapshots are there in the topic itself. But the high replication lag is a different story. As discussed earlier, the replication lag plays a role, and it will trigger the timeout behavior if it is too large. The snapshot creations will stop happening, and the broker will fail to create new snapshots, and your subscriptions will not be able to translate your positions to the remote clusters. There's another consequence is that because the broker is trying to establish the mapping for all the replicating clusters at once, even if there's one cluster that is seeing the replication lag high. For example, A to B, the replication lag is pretty much 0. But if the replication lag between A and C is very high, the failover from A to B will still see a lot of replicator messes because of AC replication lag high, the snapshot can be missed, right? So even in that case, the A to B failover will actually see a lot of messes because of the missed snapshots. Now that we have gone through all the topics and the subscriptions, failure process and everything, we just discussed that to resume the snapshot creation if one cluster is down, you'll have to remove the cluster from the namespace, right? So you have to discuss about this also. What happens when we remove or add a cluster in the namespace? The API is very simple actually to do that. The get clusters will give you the list of the clusters for that namespace, and the set clusters will just ask you the list of the clusters, and you can mute it to anything you want. If you skip a cluster while setting, then that cluster, the skip cluster will be removed from your replication mesh. And if you add a new cluster, then it will be added across your replication. So when you add a new cluster, what happens is that the existing cluster, the replicators will be created in the existing clusters, and for the replication to begin. And You will see a slight difference in the behavior of how the topics are created in the new cluster, which we have just added in the replication, right? So if the auto topic creation is false, what happens is that even though the replicators have been created in the existing clusters, the topics will not be created in the new cluster, and the replication will not actually begin. So until you actually create all the topics manually via admin CLI, the replication will not actually begin. But if the topic auto topic creation is true, then yeah, then everything works. The replicator is created, and when the replicator tries to push messages to the new cluster, then the topic will be created right there. If you remove an existing cluster from the namespace, then the replicators from the other clusters will be stopped and deleted. So their cursor information will also be deleted. The global topics and their subscriptions and their cursors will be removed in this remove cluster, and they are deleted. If there were any producer or consumers that were connected to this cluster, then they will be immediately disconnected with this error. So you can see that it is quite drastic in nature, that if you remove a cluster from the replication list, then all the topics and all the cursor state is actually removed from that cluster. So even if you later on decide to add that cluster back in the replication, then the previous state is not there, right? After adding it, the replication will start actually from the latest offset, and subscriptions and the consumers will start from the latest or the earliest offset, depending upon their configuration. By and large, I think it is pretty easy to set up these replication in Pulsar. The APIs and the client usage is actually pretty straightforward. The inner working is pretty sophisticated for the replicated subscription, and it works very well. It is a useful feature, but the fact that it stops working when one of the replication cluster is unavailable is also a drawback of it. And to handle that kind of scenario will require specific runbooks to handle it. And as we have seen, that removing cluster from the namespace can have drastic effects, right? So that runbook, that specific runbooks, and the fact that it can require a manual intervention is a setback. There are other misexpectations also around the topic creations, and all of them actually revolve around the topic creation flag only. As long as it is true, I think it works very well. All the topics are created wherever it is required. But when it is false, the behavior is inconsistent, actually. But I think it probably will be fixed in the future release of Pulsar. So coming from the Kafka, I think in Pulsar, the Pulsar is actually miles ahead in the features of the Jira application. And I think I hope that you guys have found useful from this talk. Thank you.